Hi everyone, today we're going to continue solving polynomial interpolation for a given set of data. But this time we're going to use a method called Newton divided difference, NDD. Okay, so let's look at how we can solve a given set of data using Ndd approach. We consider the similar set of data that we have used in my previous video. So we have 1, 1, and then we have 2, 4, and 4, 5. These are 3 sets of data. Now, 3 sets of data should give you a polynomial of degree 2. Okay, so your polynomial should look like this: a0 plus a1x plus a2x squared. Okay, so if you watch my previous video, I've shown you how to get this polynomial by using Lagrange approach. Okay, so with the same set of data, we can use Lagrange approach. But today we're going to look at NDD. Now NDD is very easy, so if you just walk with me with all the steps that I'm going to show. So we have this set of data, so we have we call it Ndd Table. So we have to construct the Ndd Table. So these are my x values, these are my y values. Now make sure my x value is in increasing or increasing. Okay, so I have 1, 2, 4. If you have a set of data where your x are not increasing, you have to rearrange it. So for this one, I have 1, 2, 4, and the y values are 1, 4, 5. Okay, so what we want to do is we want to find this value, and this value. Okay, so these are the goals. So we want to find all these values. So I don't know what to call this, so maybe I'll call this A, B, and C. Okay, to find A, what I do here is just 4 minus 1 over 2 minus 1. So 4 minus 1 is 3. 2 minus 1 is 1. So 3 over 1. Now to find B here, which is 5 minus 4 divided by 4 minus 2. That gives me 1 over 2. Now the C here. Okay, so we gotta be careful with the diagonal, the last. Okay, so write down the values that we have obtained. So this is now we have half. This is 3 from here. Okay, to find C, so half minus 3 divide by, now look at here, 4 minus, you gotta skip one value, so it will be 1 minus 1. Okay, so half minus 3 is minus 5 over 2 divided by 3 is negative 5 over 6. Okay, so we have obtained all the values from the table. So I can write this again as 1, 1, 2, 4, 4, 5, 3 half, and negative 5 over 6. Okay, so once we have all this information here, we can write the polynomial P2. So my P2x is given as 1 plus 3. Okay, now this is my x value. So I've told you these are my x value here. These are all my x values. So I must consider this value here. So 3x minus 1. Okay, because x equals to 1, give me 1. So x minus 1. Okay, we just have to take all this diagonal constant here. So negative 5 over 6. Okay. And then I have 2 now. 1 and 2. So I have x minus 1, x minus 2. So these are my polynomial of P2. Similar equation, if you expand this, you can obtain by using Lagrange approach. Okay, now how if you have many set of data? Okay, for example, let's look at another example. Okay, so I have this question like this. Use Ndd to find the interpolating polynomial P3 for the data points. Okay, P3, so I need at least 4 set of data. So 2, 4, 0, 5, 0.58, and for 12. Okay, look at here now. These are my set of data. So first step, I need to construct the Ndd table. So remember I told you, you must make sure you have the data's x value as increasing. So minus 2, 0, 0.5, 4. Okay, good. So minus 2, 0, 0.5, and 4. My y values are 4, 5, 8, 12. Okay, so let's look at finding all this information that I'm gonna label as. So I have my A, B, C, D, E, F. So these are all the values that I need to find. So finding A is easy. Okay, how can you find A? 5 minus 4 divided by 0 minus 2. Okay, so you have 1 over 2. Now B will be 8 minus 5 divided by 0.5 minus 0. So 8 divided by 5 is 3 over half. 0.5 is half, so that gives you 6. Okay, now C. So C here will be 12 minus 8 divided by 4 minus 0.5. So what is 12 minus 8? 4 over 3.5. Okay, so we have 4 over 3.5, 7 over 2. So I have 8 over 7. Okay, so we have obtained the first, second, the third columns of all this information. Let's put it down so that we know how to do the next. So we have half here, 6, and 8 over 7. Okay, now to find D will be 6 minus half over, now I gotta skip one step. Okay, so that will be 0.5 minus my negative 2. So I'll be plus 2. 0.5 minus negative 2. So 6 minus half divided by 2.5. So I have 11 over 2 divided by 5 over 2. That's give me 11 over 5. Okay, so similarly we need to find D. D of obtained, so E, let me just put it here. My E will be 8 over 7 minus 6 over 8 over 7 minus 6 divided by 4 minus 0. Gotta skip one step here, so 4 minus 0. Okay, so I have 8 over 7 minus 6. So I have 8 minus 42 over 7 over 4. That will give me negative 34 over 28, which is negative 17 over 14. Okay, so I've obtained E, negative 17 over 14, and D, 11 over 5. Now lastly is to find F. Okay, so for this column we have skipped 1, and here to find F we need to skip 2 values of X. So for F we have negative 17 over 14 minus 11 over 5 divided by, we need to skip 2 values, so it would be 4 minus negative 2. 4 minus negative 2. 4 minus negative 2. Okay, so let's solve this. Negative 17 over 14 minus 11 over 5 divided by 4 plus 2. 6. Okay, so this will be, okay, so we have to multiply by 5, 5, 14, 14. That gives me negative 17 times by 5. I have negative 85 over 70 minus 11 times 14, negative 154 over 70 divided by 6. So we will have negative 239 over 70 times 6, 420. There you go. We have obtained also another value, which is the last diagonal, which is negative 239 over 420. Now all I need to do is to write the polynomial equation based on these values here. Okay, so my P3, maybe I'll just erase this part. It will give me enough room. Okay, so P3 is given as P3x. Okay, so we use the diagonal coefficient value together with the x values here. So these are all my x values. Okay, to get x negative 2, I must write as x plus 2. Now to get x equals to 0, I write x minus 0. To get 0.5, x minus 0.5, and x equals to 4 can be obtained by writing as x minus 4. Okay, so the equation will be 4 plus half. Now for this half, we take this one value of x plus 2, plus 11 over 15, sorry, 11 over 5. We take two values of x, such as x plus 2, x minus 0, which is x, minus negative 239, plus negative 239 over 420. Now I need three values of x, such as minus 2, 0, 0.5, so I have x plus 2, x as well as x minus 0.5. Okay, so these are the polynomial P3 interpolating equation for given set of data. Okay, that's all. Thank you.